Hello and welcome to this SOFiSTiK tutorial. In this video, I will show you how to create a parametric superstructure family that references secondary axes of the SOFiSTiK Bridge and Infrastructure Modeler. A secondary axis is hosted on a main axis. You can see the main axis here in blue and the secondary axis with a horizontal as well as a vertical offset in red. An axis can have multiple secondary axes. How do you reference the secondary axis with a family? You can do this by having one adaptive point, which is here marked as reference 1, as well as multiple shape handle points. Here I have only one, reference 2 displayed. The first part of the family, here the top part of this girder, will follow the top adaptive point. On the other hand, reference 2 is responsible for coordinating these points that you can see here in the bottom. What is necessary for the reference point to be referenceable in your project by the SOFiSTiK Bridge and Infrastructure Modeler? First up, it has to be defined as a shape handle point, and it needs to have a name assigned to it, here as bot reference. You can then connect the two references within the family together to create your volumetric reference as a two-dimensional family for the creation of the volume in your project. Additionally, you can use this functionality for multiple things. For example, with a reading parameter, you can reference only the height of a secondary axis. You can see here that I created additionally to the already existing geometry, which is referenced with the main axis and the secondary axis for its height, I have another horizontally offset axis. When I now create a family where the shape handle point is seen here on the right, I can use reading parameters to only read the height and assign it as a parameter. This allows me to reference the height of the already existing secondary axis without the need of creating another one to only assign the height to the family. Let's start by creating a new project. I do this based on the construction template. I go to the 3D view, and in here, via SOFiSTiK Bridge, I will create a new axis. For simplicity, I will just get rid of the second two definitions for the linear development, and I want it to be 30 meters long. I also want to change the placements accordingly. For example, I want one at 6 meters and another one at 24 meters, and the last placement at 30 meters. This simply eases the process. I click on OK, and the axis is created. I can now select it and add a secondary axis to the definition of this main axis. I create this one and call it vertical by clicking on plus. You can see that the placement information is immediately taken into account here, and I swap to vertical to now define my offsets. I want a vertical offset of -2 meters, -1.5 meters, staying at 1.5 meters, and going back up to 2 meters. Why do I assign it negatively? Because I want it to be underneath my axis. Additionally, I want it to have a smooth transition from the height. I do this by assigning this point to have a transition length to the left. I can assign this simply by assigning transition left. And this point, I want to have a transition to the right of its point to increase the height development. By clicking on OK, we are already done, and you can check the new secondary axis we created right here. Now it's time to create a superstructure family. So I go to New, Family, and I want to create a new metric generic model adaptive family. I turn it to take a look at it from left to right because we are working in this two-dimensional plane to create the family. I click on point element, create this new point, and align it to the middle of my family. Can now select the point and make it adaptive. This is once more the reference point for my axis. Here I can now create the offset of the points for the top part of my eye girder. So I will set the plane for the middle plane here and create 2 more points at the center of this family. And I can drag and drop the elements directly in here. You can see I could control it either via a dimension line, but I can also just give it a fixed value. And I want this one to have 800 in its flange as an offset. So I will set 400 into both directions of this reference point. I now create the thickness of my flange by creating 2 more points in the horizontal plane of each of these reference points. And I can once more simply select both of them by holding the Control key and assigning -28 as the thickness of the flange. Lastly, I want to have 2 more points for to give me the corresponding thickness of the web. So I'd create 2 more points. And I now want to assign a thickness of 390. In this direction, I have to go negative and 390 on the right side into positive direction. This will now be my reference geometry for the top part of my flange. Can already connect it together if I feel like it by selecting 2 points and clicking on spline through points. And just keep in mind, if you were to now move this geometry or this adaptive point, all of the geometry will follow. Next up, I want to create 1 more point with a vertical offset. I do this by creating it in the reference plane of my adaptive point, simply for it to be aligned. The offset doesn't really matter because this one will now be a shape handle point. So I select the point, change its type to shape handle point. All I need to do for the program, the SOFiSTiK Bridge and Infrastructure Modeler, to recognize it later on to be selectable, I need to assign a name to it. In this case, I will call it BOTREF for bottom reference. That's all that's necessary. Now I will just create the same points as for the flange with 400 offset as well as -400 offset, a thickness of 28 for the 2 points in vertical direction. Can select both of them by holding Control and simply assigning 28 to them. And then horizontal displacement for these 2 points to represent the thickness of the web. I select it, assign 390 to it, as well as -390. I will now connect them together the same way by selecting 2 points and clicking on spline through points. You can see with the selection modus of Revit, it's very easy to connect them together. And the speciality now is that both of them, if I move them in the plane left to right, are freely defining the bottom part and the top part of my flange. I can now select the web points, top and bottom, to create the web definition. And Just keep in mind, it doesn't really matter where this shape handle point is situated, because as soon as I load it into the family, the top reference, the adaptive point, will be situated at the main axis, and the shape handle point will reference our secondary axis. I now first, before I go into the SOFiSTiK Bridge and Infrastructure Modeler part, want to assign a type name, type 1, as well as save it. And I will call this one steel girder number 1. Save it and load it into my project. I will now start the superstructure command, and here my family is directly available. I will first start by not referencing the bottom secondary axis. Simply by clicking OK, the distances that are defined in the family will be used. So you can see here it's a little bit angled. By the way, let me turn off the placement representation simply to have it a little bit cleaner. Here we can see the original dimensions. So I can go back to edit this superstructure, either select it via the 3-dimensional selection, or in the drop down we can find all the secondary axes that are available based on the main axis. I can select A vertical, and the program will automatically find the secondary axis and assign the shape handle point to it. So far so good. Let's come back to modify this main axis and add another secondary axis to it, which I will call horizontal. This axis will simply get a horizontal offset of 3000. I will do this for all the points. And the program creates another secondary axis with the horizontal offset that follows the main axis. I can now use the already existing superstructure family and base it with its adaptive point on the secondary axis. You can see once more the original geometry. And just for a showcase, I now want to connect it to the vertical reference. Let's see what the program now creates for us. As expected, it's now referencing the vertical offset as well as the horizontal offset. Let's change this. We only want this girder to reference the vertical offset, not the horizontal one. So I open up the family once more, and I want to duplicate it now. How do I do this? I will do this by simply saving it with another name. So I will save it as steel girder number 2. What is now necessary for you to easily reference only the vertical deflection? You need to assign another shape handle point. I do this by referencing the vertical plane and placing a point anywhere in this plane. I select it and change it to a shape handle point. And by assigning it a name, which I will call vertical, underline only. That's actually all that's necessary from the shape handle point. What else do we need? We need a dimension line. I place this dimension line from my adaptive point to my shape handle point. And now I select the dimension line and I want to assign a special parameter to it. I can create it right here or via family types. And I will call this one read, an instance parameter, which now will be a reporting parameter. Click on OK. And when we take a look at the family types, we can see it's actually grayed out. I can't modify it at all. Let's modify this already existing family that we have here. I want it to be perfectly aligned to the vertical geometry that we want to create later on. And now I want to change the shape handle point back to a reference point. And I want to delete its name. This point is now the defining point for all that is happening in a vertical offset from the geometry, but you can see here, this point does not have a host because we changed it from a shape handle point to a normal reference point. But we can reassign it. First up, I want it to be reassigned to the reference plane, which is this horizontal plane. And secondly, now once I selected the horizontal plane, I can also pick any other point. For example, my already existing adaptive point. Now the offset defined is the offset from the adaptive insertion point. I could now go into here and assign my read parameter to the offset. You can see because the read parameter or dimension lines always give me positive values, and the coordinate system of this point is positive to the top, it will be assigned to the top, meaning that in this case, you need to have another parameter, for example, offset, as an instance parameter of type length, that translates read into a negative value by simply assigning a minus in front of it and assigning the read parameter. I can now take this definition of the offset and change it to this variable. And even though we have a horizontal as well as a vertical offset, only the vertical offset will be assigned to this I-girder. Let's load it into the project. In here, I can now select my already existing superstructure, edit it, and reassign it from steel girder type 1 to steel girder 2 type 1. You can also see the representation as well as the available secondary axis. If I now select a vertical, we already see a preview. I can click on OK, and the family will be created as a standard steel girder reading the height information from the already existing secondary axis.